Hi fellas and welcome back to the channel. In today's video, we are building a complete line follower robot with obstacle detection and SD card data logging entirely in Proteus. Our robot will follow a black line, detect obstacle, reverse back along the same path, do a 180-degree turn, find the line again, and continue moving. Every obstacle event get logged to an SD card, which we verify using WinImage. This covers motor control, sensor interfacing, SPI communication, and data logging, all in one project. So let's get started. Here is what we are working with. 5 main components. Arduino Uno, the brain, the turtle module, combined chassis, motor driver, and 3 IR sensor, and an electro ultrasonic sensor. Detect obstacle at the front. SD card module logs obstacle event permanently. Virtual terminal, our real-time serial monitor inside the Proteus. Here is the complete pin connection. Uh, Pause and write these down. The IR left is connected to pin 2. The IR center is connected to pin 3. The IR right is connected to pin A3. Echo is connected to pin 5. IN1, IN2, and IN3 is connected to pin 6, 7, 8. ENA and ENB pin is connected to pin 9 and 10. IN4 is connected to pin A1. Trigger is connected to pin A2. SDCS is connected to pin 4. And MOSI MISO and clock is connected to pin 11, 12, 13. These pins are of the SD card and virtual terminal is connected to the pin 1. Now, here is the complete schematic in Proteus. Let me walk you through each part. So, first of all, we have the turtle module. The circular component, it has IN1 through IN4 for motor direction, ENA and ENB for motor enable, and 3 IR tensor left, center, right. At the bottom, where when a sensor is over the black line, it outputs high, white background output low. This is the foundation of our line following. The ultrasonic sensor the ultrasonic sensor here, the trigger pin is connected to A2, echo is connected to pin 5. It works like echolocation. Send a sound pulse, measure how long the echo takes to return. When we convert that time to distance, object within 15 centimeter trigger obstacle avoidance. The SD card module using SPI protocol, CS on the pin 4, MOSI to pin 11, MISO to pin 12, and clock to pin 13. In Proteus, this saves data to an actual image file on your hard drive, which we will open in WinImage later. We have virtual terminal connected to pin 1, set bound rate to 9600. In properties, all serial print out appear here in real time during simulation. let's move to the simulation. Now we click on the play. Virtual terminal show SD card ready and line forward ready. Both motor activate. Was the three light on the turtle module, center light on, robot on the line, going straight forward, approaching a curve, right light activate, robot steers to right, center comes back straight again. This is a clean three sensor lines following in action. Now placing an obstacle in front of the ultrasonic sensor, distance dropping 20 cm, 15 cm, obstacle detected. Robot stops. Virtual terminal confirms obstacle detected distance 12 cm. SD right OK. Now watch the reverse sequence. Robot goes backward, IR sensor still activate, staying on the line perfectly. After 1 second, 180-degree pivot turns, then robot creeps back forward, catches the line, lines reacquired, normal line following resume in the opposite direction. Smooth. But in the Proteus, you can see that the robot is not following the line correctly. This is not because the code is incorrect. The code is correct. As you can see, it is following the line in some parts. But as our path is complicated, so it get detached from the path. When it divert from the path, it do not the sensor sense the value is low and the robot stops. But in real life, we can add more sensors or we can place them at those locations so that we can optimize the movement of the LFR. So you guys do not uh, confuse it that the code is wrong, the code is right, but the placement of sensor in this turtle robot is like this, that the complex path is difficult for this robot to follow. Now, so first of all, we will go to the WinImage software. We will make a new files just like I have made it from LFR and obstacle. Then select the file type to, we have set the file type to IMA. After setting this, we will save this file. After saving the file, we will open the Proteus, double click on the SD card module, and on top we will find the place where we can paste the file. You can see in the video that I am doing this, and after that we have to restart the Proteus. So when we restarted the Proteus, the file is then updated. Now you can see that the IMF file of the Win image show a text file that was not here before. So when I clicked it open, you can say that my roll number and name is written, obstacle detected, the total distance, and the distance at which the obstacle is detected is written in the Win image part. And that is a complete line forming robot with obstacle detection and SD card logging. Now here is a complete firmware written inside Broadcast VSM Studio. No external IDE needed. The code is structured into clean sections. Pin definitions, motor controls, sensor reading, line following, obstacle avoidance, and SD card logging. The biggest optimization is this single set motor function inside of wiring, separated forward, reverse, and turn function with repeated digital write calls on function handle all motor state. This alone cut the code from 200 lines down to 110. Three sensor logic make line forming much smoother than two sensor. Center sensor handles straight but left and right handle correction. SD logging is triggered only on obstacle detection to save resources. Full code is in the description, completely free. Recap the three sensor line following for smooth and stable tracking, smart obstacle avoidance with line track reverse and 180-degree turn, SD card data logging verified with WinImage, clean, optimized code at 110 lines, hardware tips and common error fix. So the backstory is that their code was more than 250 lines, and I have optimized it to into 110 lines because we are working on a microcontroller. So you guys know that in microcontroller, when the code lines are less, the microcontroller work more efficiently. Instead if of that we have a bunch of lines. So that's why I have reduced the line length. Previously, when the line length was 273, the terminal shows a complete return. It is moving left, it is moving right, obstacle detected. But now you can see I have reduced it to left for L for left and right for R for right, and shortened the things so that our Arduino Uno works more optimized and faster, so that it can detect more effectively line. Because if we have more lines, it will take more time to detect the lines. So if this project helped you out, smash the like button, subscribe for more embedded system content. Full code is in the description, completely free. Drop your questions in the comments. I read every single one. See you in the next one. Goodbye.